AWS Cloud and DevOps hands-on implementation series. In previous video, we have covered load balancers and with hands-on implementation. Today is the 10th video of my AWS Cloud and DevOps hands-on series. Today we are going to talk about auto-scaling group in AWS. By the end of this video, you will know how to auto-scaling can help keep your application running smoothly and save cost by automatically adjusting the number of servers or EC2 instances based on your needs. We will go through the basic first and then I will show you how to set up auto scaling in hands-on demo. So let's get started. Let's start with the basics. What is auto scaling? AWS Auto Scaling is a service that automatically adjusts the number of compute resources, mainly EC2 instances, based on the current demand on your application. These instances are essentially the virtual servers that run your web application services or backend processing tasks. In simple words, it helps you to maintain the right amount of infrastructure at the right time. It scales out by adding instances when demand spikes and scale in by removing them when demand drops. So imagine your app is like a restaurant. During lunch hours, more customer walk in. So you bring in more staff to handle the crowd. But the afternoon, when it's quiet, you reduce staff to save money. Auto scaling does the same thing, but with the virtual server instead of people. This brings a number of benefits. First one is cost optimization, means you only pay for the resources you need. Then it improves the performance, means your application stays responsive even under high traffic. Resilience, if an instance fails, auto scaling can replace it automatically to keep your app healthy. It uses matrices like CPU utilization, network traffic, or even custom CloudWatch matrices to make the decision. For example, you could set a rule like add two more EC2 instances if CPU usage goes above 70% for 5 minutes. And the best part, it works seamlessly with the other AWS services like Elastic Load Balancing. As new instances are added, they are automatically registered behind the load balancer and traffic get evenly distributed. In short, AWS Auto Scaling ensures your application can handle varying loads efficiently with minimal manual efforts. Let's take a real world example, a big sale event on Myntra, like the end of season sale. During this sale, thousands or even millions of users visit the Myntra website at the same time to grab the deals. Without auto scaling, if Myntra had only a fixed number of servers running, their website might crash due to overload, leading to poor user experience and lost revenue. But with AWS auto scaling, as user traffic spikes during peak sale hours, more EC2 instances are automatically launched to handle the load. Once the traffic dies down after the sale, those extra instances are terminated to cut the unnecessary cost. This way, Myntra can provide a smooth shopping experience during massive traffic surge, no crashes, no delays, and no extra cost when demand is low. That's all about auto scaling group. Now let's look at the key components that make auto scaling work. First one is auto scaling groups. This is like the team manager for your EC2 instances. It controls how many instances you need running based on your setting. If you set it to have 3 instances, it will make sure that there are 3 EC2 instances running. It will add or remove instances when necessary. Then next one is launch configuration or launch templates. These are like blueprints for your EC2 instances. You decide what each instance looks like. For example, what software it runs, what resources it has, and how it's secured. The auto-scaling group uses this template to create the right kind of instances when it need to scale. Then scaling policies. These are the rules that tell auto-scaling when to add or remove the servers. For example, you can set a rule that says add more servers if CPU usage goes above 70%. This rule ensures that auto scaling knows exactly when to act. Then fourth one is CloudWatch alarms. CloudWatch is a tool that monitors your instances. It keeps the track of the how much CPU is being used, how much memory is used, and other important states. If any of these states go above or below certain limits, CloudWatch can send to signal to auto scaling to adjust the number of instances. These are the building blocks of auto scaling, and now we are going to talk about the different types of scaling. There are 3 types of auto scalings. First one is dynamic scaling. This is the most common one. It automatically adds or remove the server based on the real-time metrics like CPU usage or traffic to your application. For example, if your website gets more visitors than expected, auto scaling will add more servers to handle that extra load. Then next is predictive scaling. This uses machine learning to predict when your traffic will increase. For example, if you know that your website gets a lot of visitor during holidays, Predictive scaling will make sure you have enough servers ready ahead of time. Then third one is schedule scaling. Schedule scaling is used when you know that certain times of day or a week will need more resources. For example, if your website gets more traffic during business hours, you can schedule auto scaling to add more servers at those times and remove them when the traffic is over at night. These types helps you to manage your resources in different situations. So, dynamic scaling uses reactively scale based on the real-time matrices like CPU or request count. Predictive scaling uses machine learning to forecast the traffic spikes and adjust the capacity ahead of time. Then schedule scaling, it scales the instance automatically at the predetermined times or client demands. Let's walk through how auto-scaling works in the actions. CloudWatch monitor matrices. CloudWatch continuously checks the health and performance of your EC2 instances. It watches the matrices like CPU usage and traffic. Then scaling policies are triggered. Based on the rules scaling policies you said, CloudWatch sends the signal when it detects that something needs to be done. For example, if your CPU usage goes above 70%, CloudWatch will trigger the scaling policy to add more servers. Then the auto scaling adjusts the instance, means the auto scaling group then adds or remove EC2 instances according to policy. For example, if traffic increases, more instances are added. Then elastic load balancer distribute the traffic. Once your EC2 instances are scaled, an elastic load balancer help to distribute the traffic equally across all running instances, ensure that no instance is overloaded. It's a continuous process when your infrastructure is automatically adjusted as needed. Now we will see hands-on demo of auto scaling. Now hands-on demo overview. First of all, we will create our custom VPC for security. Then we will create a launch template, auto scaling group. Then we will add load balancer and check how this work properly. Follow my steps. Now log into your AWS console. Firstly, we will create VPC, means our custom VPC for our security purpose. Go to the VPC, create VPC, VPC only, name my VPC. Then IPv4 address is 10.0.0.0./16. Then tenancy default, click on the create VPC. Now we will create and attach internet gateway to it. Click on the internet gateway, create internet gateway, name my ICW, create internet gateway. Click on the actions, attach to VPC, select VPC, attach internet gateway. Now we have attached VPC. Now for high availability and fault tolerance, we will create subnets in availability zone. Click on the subnets, create subnet, select VPC, my VPC. Then subnet name should be public subnet 1. Availability zone will be AP South 1A. CIDR block is 10.0.1.0/24. Create subnet. Now create another subnet, VPC, my VPC, subnet name public subnet 2. Availability zone will be AP South 1B, CIDR block 10.0.2.0/24. Click on create subnet. Now we have two subnets, public subnet 1, public subnet 2. Now we will create route tables. Click on the create route table. Give name my RT1 VPC, my VPC. Then create route table. Edit routes, add route 0.0.0/0. Target is internet gateway. Choose your internet gateway. Save changes. We have created one route table. One mistake is there, we did not create a new route table because AWS automatically create main route table for every new VPC. So delete this route table which we have created. Delete. Now click on this route table. See your VPC ID. Click on action, edit routes. Now add 0.0 internet gateway, and then save changes. Now go to the subnet association, edit subnet association, then select both subnets, save association. See, we have attached two subnets and our VPC. Now to control inbound and outbound traffic, we will create security group. Go to the EC2, click on the security groups, create security group, give name WebSG. It allows SSH and HTTP. Select your VPC. Then in inbound rules, add rule, HTTP, source is IPv4 anywhere, then add rule, SSH, port 22, and click on my IP. Outbound rule, keep as it is, then click on create security group. So we have created our security group, WebSG. Now we will create target group for load balancer. To route the traffic, go to the EC2 dashboard, click on the target groups, create target group, instances, give target group name, WebTG, protocol port is HTTP 80 IPv4, select our VPC, my VPC, health check path, keep slash. No need to register target manually, auto scaling will handle it. So click on the create target group. We have created our target group. Now to distribute our incoming traffic, we will create application load balancer. So click on application load balancer, create load balancer, choose ALB, give name web ALB, internet facing, list IPv4, select our VPC, my VPC, listener port should be 80, and then select availability zones, both availability zone 1A and 1B. And then for security group, click our WebSG, which we have created in previous steps. And then in target group, create target, select target group WebTG. Now click on create load balancer. We have successfully created our load balancer. Once it is available, we will do further steps. Till now, we have created our custom VPC, route table, internet gateway, subnets, and then we have created target groups and load balancers. So this is the quick revision of your previous one, that is creation of VPC and the load balancer. Now we will go to our next part, means auto scaling. Click on the launch template. It defines the instance being details for auto scaling group. Create launch template. Give name web launch template. For AMI means Amazon machine image, quick start. Select Amazon Linux and Amazon Linux 2. And then instance type should be T2.micro because it is free tier eligible. Additional cost apply for AMI with pre-installed softwares. And then for key pair, select our created key pair. And then we will create our subnets. In security group, add our existing security group, that is WebSG, which we have created in earlier steps. Advanced network configuration, no need. Now go to the advanced detail, go below in user data, type this. Through this command we will install HTTP server, and then this message will show on that web page. Click on the create launch template, successfully created. Now we will create auto scaling group to control the scaling and instance management. Go to the EC2 and then click on auto scaling group. Here you can see auto scaling group. Tab. Create auto scaling group. Give name web ASG. And in launch template, select your launch template, that is web launch template. Then for click next. VPC, my VPC, availability zone, select both availability zones, and then next, attach existing load balancer. Attach existing load balancer, then choose from your load balancer target group, select target group, that is web TG. Then for health check, EC2 health check, and also turn on elastic load balancing health check. It is recommended. Then next, desired capacity should be 2, then minimum should be 1, and the maximum should be 3. Then click on the next. Next. This is a quick review, means our launch template is web launch template, VPC. Then we have two subnets, load balancers, target group, desired capacity 2, minimum 1 and maximum 3. Then create auto scaling group. Now we have created our auto scaling group. You can see the details here. Then for dynamic response to usage spikes, we will configure scaling policies. Now click on your auto scaling group, go to the automatic scaling, click on the create dynamic scaling, then target tracking scaling policy, then matrix type CPU utilization, average CPU utilization, set target to 60%, and then cooldown period is 300 seconds. Default is fine, then create. So we have successfully created our scaling policy. Now we will monitor and verify auto scaling behavior. Go to the EC2 auto scaling and click on the monitoring tab. Use CloudWatch for CPU and instance activity. Then you can see here network out, CPU utilization. Now go to the target groups. In target group, click on the targets, and here you will see 3 instances are created. We don't have created any EC2 instance, but auto scaling group will create it based on the demands. It automatically register or deregister the targets. Now go to the instances. See, 3 instances are running. We will simulate by verifying. Click on any instance. Instance state, stop. Refresh. Now we will stop another instance. Instance state, stop instance. Stop. See, another instance is creating because we have said desired capacity should be 2. See, this instance are creating. Now I will run this again. Instance state, start instance. Three instances are running. If I terminate 2 instances, terminate, yes, terminate. Now you will see the magic. Wait for a few seconds. Old instances are terminated when demand drops. So this setup ensures public internet access, high availability using multiple availability zones and load balancers, automatic cost-effective scaling with monitoring, health check-based replacement of failed instance. After this setup, see, we have terminated 2 instances, but these 2 instances are automatically created. Now go to the auto scaling group. In the activity section, you can see here all the activities. See, launching a new EC2 instance, launching new EC2 instance, terminating the instance, then launching new instance. You can see the activity details here. You can also simulate load or start stop EC2 instance, which I have shown you previously. Also, you can give activity notation. Click on the create notification. You can create a topic, send notification to, you can use your email ID, and event type should be launch, terminate, fail to launch, fail to terminate. From this SNS, you will get notification in email that instance is launched, instance is terminated, like this. Now you have to delete all the instance, because according to CPU matrices, instances are created if one goes down, terminated, or launched off. So keep deleting all the stuff that we have created. At this point, your auto-scaling setup should be live. You have successfully created launch template and auto-scaling group attached to an elastic load balancer and set up a scaling policies with CloudWatch alarms. This ensures that your application will scale automatically based on the real traffic demands. Now, when your application needs more resources, auto-scaling will add EC2 instances. When traffic drop, auto-scaling will remove the extra instances to save the cost, which I have shown you in demo part. Now, after deleting the auto-scaling group, see, one by one instances are getting deleted. Now see, all instances are terminated when I delete all the auto scaling group, templates, load balancer, and all. Now auto scaling group is successfully deleted. Here are some best practices for using auto scaling effectively. First one is monitor with CloudWatch, track CPU, network, and custom matrices for smooth scaling. Then set proper scaling policies. Be careful with your scaling policies, means scaling threshold. Set the rules that make sense of your application, so you don't end up with too many or too few instances. Then use multi-agent deployment. Spread your instances across different availability zones to ensure high availability and fault tolerance. Then predictive scaling. If you have predictable traffic patterns, use predictive scalings to prepare in advance and reduce the manual intervention. These tips will help you to set up more efficient and cost-effective auto-scaling environment. That's it for today's videos on AWS Auto Scaling. We have covered what auto scaling is, how it works, and how you can set it up to improve your application performance and cost efficiency. Now that we have wrapped up AWS important services till 10th video, in the next video we will start working on automation tools like CI/CD pipelines, which will help you to automate your deployments and integrate testing in your workflow. If you have any question, feel free to ask in the comment below. Till then, like, share, and subscribe. Hit the notification bell to get the latest video content. And thank you for watching. I will see you in the next one. Happy learning.